Welcome to the video lesson for section 7.1, Notes and Variation. Today we're going to discuss the standard deviation and how we can calculate it and also what it represents. Let's get started. To begin with, we have the definition for measures of variation. A measure for variation is a measure that describes the spread or the distribution of a data set. One measure of variation that we commonly use is the range. The range of a data set is the difference between the greatest and the least value of the data set itself. The standard deviation of a numerical data set is a measure of how much a typical value of the data differs from the mean. The symbol represents the standard deviation. It's read as sigma, and it's given by the following formula. We have the square root of x1 minus x bar squared plus x2 minus x2 squared plus all the way to xn minus x bar squared, where x1, x2, and xn are actual numbers from your data set. And remember that x bar represents our mean. Now, the reason why we go all the way to xn is to make sure that we include all of the data values in our data set. Then we divide by n, which is the total number of things within your data set. And last but not least, we take the square root. Let's go ahead and check this out. For our example here, the table shows the ages of contestants on two different reality cooking shows. We'd like to be able to find the range for each show and then compare our answers. In order to find the range, we want to find the oldest and the youngest age for each show and then subtract them. For show A, the oldest contestant is 31, whereas the youngest contestant is 19. If we subtract those two values, 31 minus 19, then we get 12. So the age range for show A is 12 years. That's what separates the oldest and the youngest individuals. If we move on to show B, we see that the oldest person is 48, whereas the youngest person is still 19. So we go ahead and find our range by subtracting those two values, 48 minus 19, and we get 29 as our answer. So the range for show B is much greater than show A, where it's 29 as opposed to 12. For question B, we can see that after the first week, the 25-year-old is voted off of show A, whereas the 48-year-old is voted off of show B. Our question is, how does this affect the range of the ages of the remaining contestants on each show? Well, we can see that if we take out the 25-year-old from show A, that it's not one of our minimum or maximum age values, so your range for show A is going to remain at 12. However, if we go ahead and take out the 48, that was our oldest age in show B. The next oldest age is going to actually end up being 32. So when I go to calculate my new range, I have 32 minus 19, which is equal to 13. So the range for show B has decreased dramatically from 29 to now 13, and your ranges are much, much closer. All right, we have 6 steps to help us actually find our standard deviation. Step 1 is we want to find the mean. So remember that is x bar. We're going to add together all of our values and divide by n to find our mean. Then we're going to find what is called the deviation of each value. And to find that, we're going to subtract the mean from each data value. So x1 minus x bar, where x1 is going to represent one of our actual data points. Once we've done that, we're going to go ahead and square each one of our deviations. So again, this would be x1 minus x bar squared. And then we're going to add them all together, and we're going to get a number. That number again represents the sum of all of the deviations squared. So you're going to be doing x1 minus x bar squared plus x2 minus x bar squared all the way to xn minus x bar squared. We add that all together to get some value. And then we're going to take that value and we will find the mean of our variance. So I'm going to divide that by n. So we have whatever that number ended up being, we're dividing that by n. And then our last step is to take the square root. So we're going to take the square root of our variance. And again, the square root of your variance is the sum of all your deviations divided by n, which is how many terms we have. And that gives us our standard deviation. For interpreting our standard deviation, we have two main interpretations. A small standard deviation tells you that the data is clustered around the mean, whereas a large standard deviation would tell you that the data is more spread out. So the smaller standard deviation is, the smaller the data is spread out away from the mean or from the middle of the data set. Whereas the larger the standard deviation is, the more spread out the data is away from the mean. For example 2, the top 5 contestants from a cooking show have the following ages: 20, 25, 29, 30, and 31. We would like to use those ages to find the standard deviation and then go ahead and interpret it. When we're finding our standard deviation, again, your first step is to find the mean. So if I were to add all of my numbers together and then divide by 5 because there are 5 contestants, I get 27. For our next step, we're going to go ahead and subtract the mean from each one of our individual data sets. So we're going to go ahead and take 20 and subtract 27. And then we have 25 minus 27, 29 minus 27, 30 minus 27, and last but not least, we have 31 minus 27. Okay, so I'm going to go ahead and write down our results. We have -7, -2, +2, +3, and 4. For our third step, we're going to go ahead and square each one of these numbers. And it's important to note that when we're squaring a negative value, it is always going to end up being a positive because a negative times a negative is positive. So we get 49, 4, 4, 9, and 16. Okay, I'm going to go ahead and add all of my squares together, and I end up getting 82. I've run out of room, so I'm going to go ahead and continue this example on another slide. All right, so just to remind you where we left off, we found our mean, which is 27. We subtracted the mean from each one of our terms to find our deviation. Then we squared each one of our deviations and added them all together to get 82. What we're now going to do is take that sum, that value, and we're going to divide by n. And in this case, n is going to be 5 because there are 5 different terms. And we'd also want to take the square root to help turn that into our standard deviation. And we get approximately 4.05. Which isn't a relatively small standard deviation, but it's also not very large. But it definitely tells us the spread of our data is going to be a little large. And we can see that for our values 20 and 7. So 20 is 7 away from its mean, whereas for our last one, 30 is 4 away from the mean. So there's definitely going to be a little bit of range with our values deviating from the mean here. All right, guys, your turn. Go ahead and carry out the steps to find the standard deviation, and then check back in and see how you did. Okay, let's see how you did. So to begin with, we want to find our mean, and our mean is adding up all of our individual data values, which would be 42, divide that by 7, and we get that our mean is 6. Once we have our mean, we're going to go ahead and subtract our mean from our individual data. So I have 1 minus 6, 4 minus 6, 6 minus 6, and 9 minus 6. We're going to eventually square them, so you can see that I have each one of those expressions is squared. I did my subtraction, so 1 minus 6 is a -5, so we have -5 squared. 4 minus 6 is -2, so we have -2 squared. Then we have 0 squared, 3 squared, 4 squared, and 6 squared. When I simplified all my squares, remember that squaring something makes a positive. So -25 squared is a positive 25, -2 squared is a positive 4, and then we have 0, 9, 16, and 36. By adding up all those numbers, I get 90. I'm then going to take that 90 and divide it by 7 because I have 7 different terms in my original data set. And I would also take the square root, and I get approximately 3.59 as my standard deviation. Hopefully you guys all got that. Also, I just want to point out that our standard deviation is a little bit smaller than it was for our last example, and that should make sense because the numbers are a little closer together when comparing them to the mean than our last data sample was. For data transformation, it is a procedure that uses a mathematical operation to change a data set into a different data set. So we can be adding numbers, subtracting numbers, multiplying or dividing, and we're going to be changing the actual data numbers within our set. For our data transfer with addition, we can see that when a real number k is added to each value in a numerical data set, the measures of center of the new data can be found by adding k to the original measures of center. So this applies to our mean, our median, and our mode. So if I'm adding 10 to every one of my values, then I'm also going to add 10 to my original mean, median, and mode to get the new mean, median, mode after we have transferred our data by addition. In terms of variation, the measure of variation is going to be the exact same as the original measures of variation. So if we had a standard deviation for our data set and we added 10 to everything, they're still going to be spread out the exact same distance from our mean, so the standard deviation would again be the same. For our second type of data transformation, we have data transfer with multiplication. So each set is now going to be multiplied by a real number k, where k is something greater than 0. And the measure of center and variation can be found by multiplying the center measures by k. For our example here, we're going to go ahead and try and find the mean, the median, and the mode after a given transformation. And in this case, each data value is going to be increased by 20%. So what I'm going to do is I'm going to find the mean, median, and mode for the original data set, and then I'm going to transfer that by increasing it by 20%. The first thing I'm going to do is write this in increasing order. So we start with 9, 12, 15, and 17. Okay, for our mean, I'm going to add them all together and then divide by 4. We end up getting that our mean is 13.25. For my median, I have two middles. I have 12 and 15. So to find my true median, I'm going to average those. Again, that means I'm going to add them together and divide by 2. So when I find my median between 12 and 15, we end up getting 13.5. Now there is no mode because for this data set, each value occurs once, and if they all occur the same amount, then there can be no mode. So what I'm going to do now is I'm going to go ahead and identify what my new median and mean would be by increasing them by 20%. Now an increase by 20% means I'm going to be 20% above what my original value was. So I'm going to take my mean and my median, and I'm going to multiply them by 1.2 to increase them by 20%. So if I go ahead and multiply each of those values by 1.2, then my new mean is going to be 15.9, and my new median is going to be 16.2. Now I could have gotten those exact same values if I would have taken each one of my original values and multiplied them by 1.2, and then found my mean and my median separately. Or, as I did here, we can find our mean and our median for the original data set, and then I can multiply those by 1.2, showing my increase of 20%. All right, that does it for our note today. Go ahead and get started on the homework, and good luck.